have all heard the terms metals and non-metals. Can you look around and see if they exist in your surroundings? What is your table made up of? Aluminium or wood? What about the phone or the laptop you're viewing this video on? Is it made up of metals and non-metals? As a matter of fact, it is. Almost everything around will be made up of either a metal or a non-metal. But how do you differentiate between the two? Is it as easy as the difference between the two colors black and white? Well, for that, let us look at the physical properties of each category in detail. Let us take, for example, the ornaments. Any of the ornaments will do. What do you have to say about them? You will observe that most of them are made up of gold or silver. Let us look at them closely. Do they have a shining surface? Or even the aluminium utensil in the kitchen? Does it shine? Of course, both gold and aluminium have a certain shine. Do you know what this shine is called? Well, it is called luster, and as both gold and aluminium are metals, this is known as metallic luster. Now we know that metals have a metallic luster. Now if the utensil drops on the floor, does it break into parts? No, right? That is because metals are generally hard in nature. However, this hardness varies from metal to metal. A very thin plate of gold, for example, can be easily broken with a little pressure. Plate? Did I say plate of gold? How do you think huge aluminium sheets are made? Or sheets of copper or zinc? If I take a hammer and beat them, will they break or will they turn into sheets? It is the amazing property of metals to be beaten into sheets. And we call this property of metals as malleability of metals. Most metals can be beaten into thin sheets. Do you know another important property of metals? Have you ever seen copper wires or thin gold wires used to make jewelry? Metals, by nature, can also be drawn into wires. Do you have any clue as to what this property is called? It's called ductility of metals. The ability of metals to be drawn into wires is called ductility. There is an amazing fact I want you to know. A single gram of gold can be drawn into a 2-kilometer long wire. Isn't that amazing? Well, there are some more interesting properties of metals which we will learn in our next lesson. We learned 4 properties of metals in our earlier video. Can you name them for me? Metallic luster, malleability, ductility, and that they are hard. These were the 4 properties, right? Can you think of some more properties of metals? Metal utensils are used for cooking, aren't they? Why do you think they're used for this purpose? Which energy do we need to cook food? Heat energy. Correct. We need heat energy to cook food, and metal utensils are good conductors of heat. They help transfer heat evenly through the entire surface and provide even heating. No doubt, most metals are known to be good conductors of heat. Do you know the 2 best conductors of heat? They are silver and copper. 2 other metals like lead and mercury are comparatively poor conductors of heat. Electric wires were also made up of metals, right? Why is that? It's because they are good conductors of electricity too. If we have a battery and a bulb connected in a circuit with a metal wire, you will see that the bulb will glow when the switch is closed. And because they are good conductors of electricity, they are coated with rubber-like material. This rubber-like material acts as an insulator which protects us from being electrocuted if we touch the wire by mistake. Do you know any other property of metals? What happens when we strike a metal on a hard surface? Like utensils banging against the sink. Can you hear a sound produced by metal? Yes, this is another property of metals. We can call metals as sonorous, meaning they produce sound when hit against a hard surface. No doubt, school bells, church bells, or the bells in a temple are made up of metals. If these are the characteristics of metals, What do you think will be the characteristics of non-metals? In simple words, just the opposite of metals. In a nutshell, non-metals like carbon, iodine or sulfur do not have luster. They do not shine and are brittle in nature. What do we mean by brittle? They cannot be beaten into sheets or wires as most of them turn into powder when hit by a hard substance. Non-metals can also be gases like oxygen, hydrogen or solids like carbon, sulfur, etc. Do you know of any non-metal in the liquid state? Bromine is the only non-metal which is in the liquid state. Non-metals do not conduct heat or electricity, and they do not produce that sound when hit against a hard surface. This means that they do not have the property of sonority. So isn't it easy and simple to differentiate between metals and non-metals only on the basis of their physical properties? Wait, but mercury is a metal in liquid state at room temperature and bromine is a non-metal in a liquid state at room temperature. How do we differentiate between the two based on physical properties? We can say that all metals are solids at room temperature except mercury, and all non-metals are either solid or gaseous except bromine. Well, this is not it. There are a few more exceptions that break the physical appearance norms of metals and non-metals. For example, most metals have high melting point, which means that they need a large amount of heat to melt. But look at the two metals gallium and cesium. They melt when you keep them on your palm. We must say then that these two metals have a very low melting point. Look at another exception in non-metals. Iodine, for example, is a non-metal, but it has a property of the metals. Can you point out which property I'm talking about? Correct, the luster. Iodine has shine or luster, which is technically the property of metals. Take another example, carbon, for instance. What is carbon? Is it a metal or non-metal? Yes, carbon is a non-metal, but look at diamond or graphite. They all come from carbon. They are known as allotropes. The different forms in which carbon can exist are called its allotropes. Let us look at the allotrope diamond of carbon. It is known as the hardest substance and has an extremely high melting point and boiling point. Aren't these the properties of metals? But it is surprising that diamond is an allotrope of carbon, which is non-metal. Diamond too is a non-metal which strongly exhibits the properties of metals. Now that we know of so many exceptions, do you think it's easy to differentiate between metals and non-metals based on their physical properties? I doubt that, but don't worry. There is another way out of this. It is to differentiate the two based on their chemical properties. How is that done? For that, you will have to watch our next lesson. We saw that elements cannot be clearly classified into metals and non-metals based on their physical properties. Will chemical properties help? Let's understand chemical properties of metals first. When we're looking at chemical properties of metals, there are a few things we will look at. We will see what happens when metals are burnt in air, when metals react with water, when metals react with acids, and lastly, when metals react with solutions of other metal salts. Now in all these four categories, there's just one simple thing we will do. We will look at how reactive the metals are. If the metals react easily, may it be with oxygen or air or anything else, we say that they are more reactive. When it's more difficult for them to react, we say that they are less reactive. Let's focus on the first category. Metals burnt in air. The most important points to note here is that almost all metals react with oxygen to form metal oxides. These metal oxides that are formed are usually basic, but they can also be amphoteric. What do we mean by amphoteric? Metal oxides which may show acidic as well as basic behaviors are known as amphoteric oxides. Most metal oxides are insoluble in water, but some may also dissolve to form alkalis. Okay, so metal oxides being formed in one thing, but do all metals react with oxygen at the same rate? Not really. Different metals show different levels of reactivity towards oxygen. Alkali metals such as sodium and potassium react vigorously with oxygen. In fact, they react even if they are just kept in the open, that is, at room temperature. They don't even need fire to ignite the reaction. What about the other metals? Metals such as magnesium, aluminium, zinc and lead also react with oxygen at room temperature, but they react a bit differently. When they react with oxygen, their surfaces get covered with a thin protective layer of oxide. This layer protects the inner part from being oxidized. What about iron? Iron doesn't burn on heating, but iron fillings burn vigorously after being heated. And which metals do we have at the end of the spectrum? Yes, silver and gold. Can you guess how they react with oxygen when burnt? Silver and gold do not react with oxygen at all. Yes, they don't react even at high temperatures. So we see somewhat of a pattern event amongst the metals. Sodium and potassium are more reactive, whereas magnesium is relatively less reactive. But wait, burning in oxygen doesn't really help us to decide about the reactivity of zinc, iron, lead or copper. All we know about these four is that they form a thin layer of oxide around the metals. So just this category of burning metals in air isn't enough for us to judge the order of reactivity of these metals. We can see a few more reactions to judge the order of reactivity. So in the next lesson, we will see how metals react with water.